Hi all, welcome to the International Symposium of Big Data, AI and Education. My name is Jong-wook Woo, and I'm a general chair of the symposium, and I teach at California State University, Los Angeles. It is my pleasure to introduce President Kang In of Seoul Cyber University with her opening remarks.
Distinguished speakers and participants, ladies and gentlemen, I'm very honored to host the International Symposium of Big Data, AI, and Education. First of all, I would like to express my sincere gratitude to Dr. Jong-wook Woo, professor at California State University, Los Angeles, for his support in organizing this symposium. Also, special thanks to Dr. Regis Rajamohan, Senior Developer Advocate at Databricks, Dr. Sang-hoon Lee, Professor of Yonsei University, Dr. Jo Bungo, DLI Program Manager, Nvidia, and Dr. Ji-young Chun, Professor of Seoul Cyber University, for participating in this symposium as speakers and panelists. Furthermore, I'm grateful to Professor Yoon Na-kim, Director of the Future Society Research Institute of Seoul Cyber University, for organizing the program. As you may know, Databricks and Nvidia are globally known as champions of big data and AI in Silicon Valley. Through this symposium, I hope that the present and future trends in information technology will be discussed and insights given to students of Seoul Cyber University. Thank you.
Okay, so thanks, President Kang In. And our first speaker is Dr. Rajamohan. He's the Senior Developer Advocate in the Division of Data Science and Machine Learning of Databricks. And his talk title is Deep Learning at Scale with the Databricks. Dr. Rajamohan, can you share your screen and start your talk?
I will do that. Can everyone see my screen?
Oh, sure. Yeah, I can see it.
Awesome. So thank you everyone for attending my talk today. So I hope to talk about how Databricks enables deep learning at scale and some of the frameworks and tools that we have made available for doing exactly that. So Databricks is a company that is known for enabling data science and machine learning solutions, and it's been widely renowned in the open source space, primarily for Spark, but ever since then, it has sort of developed MLflow and Delta Lake to complete that machine learning or MLOps pipeline. So we also added Koalas and Redash recently for our business intelligence applications as well. So building upon that esteemed open source infrastructure and heritage, Databricks is actually on a mission of enabling data analysts, data scientists, and data engineers. So we're building this unified data and AI or machine learning infrastructure to make sure that people can do machine learning or deep learning problems at scale. So how exactly do we do this, and what are some of the things that we want to enable? So obviously, we want to enable some best practices for machine learning, starting with software engineering practices that are applied to code. We also wanted to make sure data practices are done appropriately to make sure that we validate our data. We have no data drift that would render a supervised model ineffective. So we do things like schema validation, and we check for model and concept drift. We also want to version and track our experiments like code. So for example, we want to make sure that when we change hyperparameters or input our code, we're doing this in a systematic fashion. We also want to monitor our predictive performance over time to make sure that our model performance does not degrade over time. So this is to ensure, we also want to ensure that model fairness across different classes or data does not become a problem. So we're accounting for things like model bias. So I want to start out by actually talking about ML ops and defining this term. So it really consists of just ML, which is our model, and data ops plus DevOps. So DevOps is a term that probably most people are familiar with, where we're actually using software engineering practices to our operations and infrastructure. So data ops is probably a less familiar term. All it means is that we're applying the same principles and dealing with data as code, in the sense that we're doing version control. We want to make sure people can collaborate and work with data. So our entire pipeline looks something like this. So we're starting from the model build, then we have the test, then we deploy our model. We want to make sure that once it's deployed, we can monitor it. And once you obtain the feedback, if we have to, we go back and continue with this loop of building our model. So this is our model management lifecycle. So what is the Databricks ecosystem for machine learning and deep learning? So moving forward, I'll just refer to this as machine learning. So keep in mind, this refers to machine learning, deep learning, or anything you'd consider under the umbrella of AI. So all of this starts with an integrated environment. So this is centered around a notebook environment that can be attached to any of the computer instances from the three major vendors, cloud vendors, that is AWS, Azure, or GCP. So we want to make sure our notebooks are version controlled using things like GitHub. So if we've used something like Jupyter notebooks, it's fairly similar in concept. So all of this is tied together using what we call the DBFS file system, which is nothing but a Linux file system. So you can use, you can run your file system commands. You can also mount cloud file systems like S3 if you so choose. So you also have the ability to mix SQL code, Python, R, and Bash in the same notebook. And you can also do things such as scheduling your jobs to run at any time. So Databricks enables your data scientists by providing what we call a Databricks runtime. So these are essentially images or pre-installed images that come with all of the machine learning or deep learning frameworks that are popularly used. So anyone who's done machine learning knows that a large amount of time is actually spent installing packages or setting up your infrastructure. So the goal is to make sure that you reduce some of that time for your data scientists. Of course, there are always packages that aren't available in these images. So you can install additional packages into your cluster or per notebook. And last but not least, you have MLflow, which is integrated into our Databricks Lakehouse platform, which provides three distinct capabilities. So it's useful for model tracking, for experiment management, or reproducibility. It also allows you to package your machine learning projects, so you can distribute them and collaborate with other folks. And MLflow also has mechanisms built in for serving your model, so you don't have to go to an external tool to serve your deployed, created model. So just want to give you guys a little walkthrough of what this interface looks like. So once you log into the Lakehouse platform or the Databricks platform, you'll see something like this. So you'll have your recently viewed files along with some documentation at the top and a nav bar to the left. So the nav bar is a fairly rich, feature-rich nav bar where you can inspect your workspace. You have the repositories that you have connected. You have the data you may have uploaded. You have the compute instances that you can spin up, any jobs you may have scheduled, your experiments that you run, your feature store, and your model. So everything is accessible from the nav bar here. So looking at what that notebook interface looks like, it's fairly similar, as I mentioned, to a Jupyter notebook or a Jupyter Lab interface. So you have the code here that you can execute by clicking on this button here, and you see the output below. But you can also attach this notebook to a cluster. If you look to the top left corner, here's a drop-down button that allows you to attach to any of the compute instances that you've spun up. So you have CPU and GPU-based instances available depending on the workspace you're in. And to the right, you see some of these widgets here that allow you to share these notebooks and collaborate with other users. You can also version control them and share and actually store them in GitHub. You can also have MLflow integration if you're using the non-community version. So all your experiments that you run are automatically logged. So you can schedule these notebooks to run at any time. And if you go to the Jobs tab, you'll see something like this, where you have all the jobs that you scheduled that you can search and index, and you can see the status of your last run. So if you wanted to, you could even kickstart another job. So if you go into one of these jobs, you'll see all the information for your historical ones and the status of these jobs and how long it took. And you can even see the status of your current job. So if you don't want to schedule it, you can even kickstart a job by clicking this Run Now button here. So you have a lot of information for your current job. And as I mentioned, all your experiments are automatically tracked. So within your workspace that you have access to, you can see all the experiments that you ran. So you can filter and search through them and find an experiment that you may have run or someone may have shared with you. So once you find an experiment, one of the things that we would want to do is probably look for a model that you think is ideal for your production or your research use case. So what you can do is you can register these models. So by registering, what I mean is these models are available for yourself to use in another project or for someone else to discover and use. So you're enabling reproducibility and discoverability using these registered models. So moving on to the first step in our model ML ops pipeline is data preparation. So at Databricks, we firmly believe in the Delta Lake architecture. So it allows you to take either streaming or batch data and save it in what's essentially a Parquet file with some very nice features on top. This enables everything from business analytics to machine learning applications. So what this is, it is built on the open source Parquet file format, which allows you to have scalable metadata for really large files. It has things like time travel. So you can version your data so that you can go back to your previous version of your data if you think your model is, if you want to see how your model is performing on prior data, or for just simply for auditability reasons. It also performs things such as schema enforcement, which becomes really important when you're doing things at scale, because you don't want corrupt data to go into your streaming or your training pipeline. So all of this is good, but how is this important? How is this useful for machine learning? So data that's stored is only so much useful unless you get features out of it. So almost all machine learning algorithms take features from the data for its training purposes. So what we do is we can use one of many ETL tools to take data and convert it to features and save them as a feature store. So features tables are once again nothing but Delta tables. What's great about this is that it makes it discoverable and reusable across an entire organization. So now you're not recreating your features every time from scratch when you need to run a new experiment. Those features are saved with metadata, and someone else can also find and reuse it. So you can imagine in an organization how much time and effort would be wasted where people are cleaning and recreating the data over and over again. Additionally, it also allows for consistency for your data engineers, your data scientists, and ML engineers. They're all seeing the same data. And it also allows you to track feature lineage in a model. So as I mentioned, there are many ways you can actually perform this feature transformation. For scalable ETL, I would recommend PySpark, which is ideal for large data. If you have smaller sets of data, you can always use Pandas, and you can use the TensorFlow TF data or the PyTorch data loader to load in the data and process it. So PySpark or the Pandas API on Spark, which used to be called Koalas, can work with really large data sets across clusters if your data is too big to fit on a smaller or an individual cluster. So you can clean and prepare the data, extract the features, and perform EDA. Next up is the model build. So as I mentioned, Databricks provides DBRs, which has your favorite deep learning frameworks or machine learning frameworks such as TensorFlow, PyTorch, Keras, or Scikit-learn pre-installed. It has integration with MLflow for model tracking. You can do things such as hyperparameter tuning with HyperOptuna, and you can actually run your single node cluster with multiple GPUs, depending on the cluster you've selected, or you can perform distributed training on multiple nodes with Horvath. So the Spark clusters are pre-installed so that it is fairly easy to identify these or recognize these different nodes on these clusters. So we have NVLink or NICL-enabled instances available for accelerating these deep learning workloads. And there are a couple ways in which you can do this. You can have the tightly coupled flow where you train directly in Spark data frames with the Horvath estimator API, or you can use the Horvath runner to train on distributed Spark clusters, it requires a little bit more setup. So Databricks does recommend the Horvath runner from the Spark DL library. It is more flexible. So all you would have to do is just, let's just say you have your regular train function or method. Very minimal setup is required. So you initialize your Horvath. The next thing you would have to do is make sure your data is distributed. So if you've used the distributed data parallel in PyTorch, it's fairly similar to that. You're getting a distributed data sampler for your data set to make sure that each rank or your node has a specific subset of your data. Then the next thing you need to do is make sure your optimizer is distributed. So it needs to do distributed optimization across the nodes. So once you've done that, that's pretty much all you need to do in your training method. Then you invoke a Horvath runner with the number of nodes you've distributed your code to. And you just say that object.run, pass your function, train function, and any additional arguments you need for that. And it should be able to distribute your code and run it across the nodes, either on CPUs or GPUs. Inference is pretty similar. You can, once you created that model, all you would have to do is just load it. And you can do model.evaluate on your data set to perform inference on the model that you trained in a distributed fashion. So skip a few of these slides in the interest of time. And I'll move on to model tracking with MLflow. So the MLflow has, as I mentioned, 3 different functionalities. The first one, and probably the most important, and in terms of how people use it, is the tracking API. So it has integrations with most of the common machine learning and deep learning tools, such as scikit-learn, PyTorch, TensorFlow. We're working on some of the Bayesian tools as well. What it can do, it logs your metrics and your artifacts or your output files. So it can be logged either locally or to a remote tracking server. If you're using the Databricks interface or the platform, there's a tracking UI that's built in that can be used to query your runs and visualize the results of a run. It can also save your models and load the models at a later time from a specific MLflow path. So for example, this is what it would look like if you were to do it manually. So you would log these parameters. So I'm using Keras here. So I'm logging these individual parameters from my neural network and the metrics that I computed. And you can also log individual directories for things such as image files. And you can even log your entire model, as you see here. However, if you are using one of these libraries that have integrations, you can just simply use the auto logging feature and say mlflow.sklearn or your library of choice .autolog, and it'll automatically take care of logging all the metrics for you. So it's really that simple. The recently released functionality is AutoML. So currently, we only support machine learning algorithms for now. It works with 9.1 LTS ML DBR and above. So if you're using that, it should work fairly seamlessly. Currently, we support classification and regression algorithms. The ones that we do support are listed here: decision trees, random forest, logistic and linear regression, XGBoost, and LightGBM. So this does actually cover a majority of use cases for the customers at Databricks. We also have forecasting using the Prophet API. So you can either run it from the UI or use the command line API for running AutoML experiments. So it really is as simple as saying, I have the data in a data frame that is trained at DF, and we provide the target column. So this is a supervised prompt. So I provide the target column here. And the data directory is nothing but an intermediate directory to store our run. And we provide 2 parameters that controls how long we run our experiment. That is the timeout, which we're saying is 60 minutes, or the maximum number of trials run. So if our experiment gets to 60 minutes and we don't finish the 1,000 trials, it'll exit. And what you're seeing on the right-hand side is the output object that we get. So it lists all the metrics for the best model that we're able to obtain. You can also use the API to get more information about the experiment.
Dr. Rajamohan, you have 10 seconds left.
I'll try to get through the final few slides here. So as I mentioned, you have AutoML that can actually load the best model, and you can use that using PyFunc and perform inference on it. Skip that part. And I did actually want to talk about model inference and mention that Pandas UDF is the recommended way for performing distributed inference. So either you can take a batch of data using Pandas UDF or an iterator of a batch of data. So if you have a machine learning model, for example, here, that you want to perform inference with PySpark, all you would do is just using a Pandas UDF here, that you have a decorator and you have the model here, and you perform inference on that entire data set. So you're applying that model to this column here. So it's fairly simple. And model packaging and model serving are my final two slides here. I just want to mention that these are available for making sure that your experiments are reproducible. So you can package your machine learning code and share it across with your colleagues by simply providing an ML project file in your folder. So it has a name, an environment for your experiment, and along with an entry point and some parameters. So all you would have to do is just say MLflow run folder and overwrite any parameters. And MLflow does provide, as I mentioned, a serving functionality. So you can say MLflow model serve, path to the MLflow along with the port, and it will run your model, or you'll serve your model where you can actually send call requests to and get results back. So with that, I will wrap up, and I don't know if I'm taking questions right now or later, but happy to answer any questions anyone may have.
Thank you, Dr. Rajamohan. Yeah, we can talk about it at the panel discussion. So see you soon at the panel discussion. Our next speaker is Professor Sang-Hoon Lee. He leads multi-dimensional insight lab at Yonsei University, Korea, and his research topics cover the AI and big data with the quality assessment and avatar modeling at Metaverse. And he will talk about multi-camera studios for high-quality 3D data acquisition. Professor Lee, you may start it whenever you.
Yeah. Hi. Thank you for introducing me. And today I'm talking about multi-camera studios for high-quality 3D data acquisition. I'm Sang-Hoon Lee. I'm from Yonsei University. As you know, we have been using a lot of times recently Zoom and Google Meet and Microsoft Teams and Skype. But however, this is 2D, but we want to extend the 2D video conference to 3D. In the 3D domain, we may expect we can able to convey our emotion with a much degree of freedom, and also the people participate. Give a talk with each other with so much freedom over the 3D virtual space. Yeah, this is a type of example of metaverse virtual 3D space. When we making this virtual 3D space, the important thing is the human modeling, because human made the major character to participate in this visual conference. And also we need to model the 3D objects. And one thing, after getting this human information and object information, we need to make a virtual space. Definitely, this in order to make a virtual space, we need a very solid platform, which has been provided and which has been developed by the huge company. And after that, user can talk with each other over the networks. And recently we have a lot of bandwidth over wireless, so user enabled to talk from the end to end. However, when we get into this virtual space, we need some verification and authorization and so on and so forth. So I think in order to build this huge virtual space, I think the platform company will be provide, and they have maintaining they have maintained a huge database and AI technology plugging into the this virtual platform. And so in such a case, the user can just simplify their task to summarize what they are doing and what they want to put in. And so users just send us simple information, but most of all, this clouding company and also the database, they are doing the major goal. Okay, so this is a current 3D platform. If you take a look at this one, and they are trying to shaking the hands, yeah, but it is quite unnatural. Yeah, they you can see the interaction is so natural, and also they are doing the high five, but the hands can exactly match with each other. So the major factor and current system has they have a lot of delay due to the massive data size. If we make us processing speed a little faster, this one is reserved. However, the major problem is a realistic description. So in order to resolve this issue, AI technology must develop in the platform. So there are three major components to build up the human characters. Definitely face and also body is a very important issue. However, we need this garment information. So the garment implementation is one of the key challenging issue nowadays. And so after building up this 3.1, and we can make an avatar. This is a camera system we want to make a virtual human objects. And we set up the 54 DSLR camera, and also we set up the RGBD camera, 18 RGBD camera. So after building up this camera system, we are able to get the point cloud information. However, according to the camera distance, sometimes it is difficult to get the face information. So we set up another one to extract more detailed face and the hair and something like detailed information. So this camera distance is a little bit shorter, and from this one we get the body information. So this is a type of result. We got the camera system. We get the point cloud information from this student, and then apply the texture information on it. We get a real human character. However, there are a lot of data size going on there. And so here, if we're using the full camera, right? And so to implement the point cloud using the full cameras for full HD quality, we need 8 gigabps. If we get the compression ratio 10%, right? We need to get 800 megabps. Is a huge data size. That's the reason why all the things should be implemented on the clouding server, I think. So in the user side, we want to simplify their character by just extracting the human attributes. So if we have in your handset, in your handphone, if we have your own character like this, then send this character to the server, and so the server, the AI program is running, and then all the synthesis is going on the server, but user side, we just keep our private this data and then summarize it, and so we can reduce the data bandwidth. Data transmit data remarkably. So it is very important to get small data size in user. So when you, this is a type of example. In order to, rather than sending this actual human, right? If we model this human like this way, and we just send attribute to the server realize the behavior of the human. So in such a case, we can reduce the data size. Okay, so this is one of the example. If we send this human attribute to the server, in the server, let's assume that server has AI program, and then they use deep learning mechanisms such as GAN, then they realize the synthesis. So this is one of the examples. Yeah. Actually, this guy is my student, and they send some about attribute to the server, and they also they give us some the genre what they want to synthesis using the attribute. So in the server realize this dance according to the user request. So this is a type of a scenario we have. So this is a whole picture, and user side, they send the attribute to the server, and server realize that this virtual space, and then the system just check the authorization, and also here user download their attribute into the server. And so all the things are built into the database, and they interact with each other over this virtual space with a low delay. That is our scenario. And this is one of the things, how can we build up database using the multi-camera? So you can see a lot of information is coming out from this data. And however, there is RGB data and also skeleton data we can capture from the camera, and all the features attract from each information and build up the database. Before building a database, we need a type of linear classification, which extract pose features and also action prediction and RGB features. All these features are aligned in the database like this form. And this is one thing we are thinking about. Each from the camera system, we get extracted 3D motion and motion sequence, and they information segmented each part, and then build up each segmented motion and plug into this database while we analyze their features. And this is a type of thing so we are thinking about. And so I just want to show the slide in appendix. Oops. So this is a type of things in the VR. VR is just mainly the game. You can see we have an advantage, a high video compression efficiency, and but all the things should be controlled in the clouding server. Yeah, so it's quite reasonable, right? Yeah. This is an AR scenario, right? In order to implement clouding server AI algorithm, right? We need to capture the real space, the feature of real space into the clouding server. Clouding server manipulate the real, real world, and then plug into this character, and then send it to the user side. So AR scenario, a little bit, we need high techniques. So this is a type of things, just to combine together. This is object, virtual object, project into the real space. Yeah, AI. So the other things is a 360-degree image sequence for the implemented VR. Yeah, so this one, we don't have so much freedom on it, but the clouding server recognized all the geometric structure of a 360-degree image sequence. Yeah, so this is a type of scenario. How can we management all the data between the clouding server and the user? Okay, that's it. Thank you.
Thank you, Professor Lee. Talk to you soon at the panel discussion.
Okay.
Okay, our next speaker is Mr. Joe Bongo. He's a program manager of a Deep Learning Institute of Nvidia. He will talk about bringing GPU accelerated computing, AI, and data science to the classroom.
Okay, thank you very much, Jean-Luc. Okay, so thank you very much for the introduction. Again, my name is Joe Bongo, and I work in NVIDIA's Deep Learning Institute. The Deep Learning Institute is effectively NVIDIA's training organization. So this is where we train developers, data scientists, students, engineers on how to use GPUs and accelerated computing and deep learning to solve their problems. So our training takes a couple of different formats. So we have instructor-led workshops that are delivered by a certified instructor. And I'll talk a little bit about that program. And then we also have online self-paced courses that allow students to go through courses on their own at their own pace. Also, with each course, the courses allow developers and students to the opportunity to get a certificate in each course based on some assessments that are available in the course. And so our course content covers really all aspects. So even though our organization is called the Deep Learning Institute, we also cover accelerated computing, so how to use CUDA to accelerate scientific applications that have nothing to do with deep learning. So it really covers all aspects of technical training within NVIDIA. We do have fundamentals courses, we have advanced courses, we have industry-specific courses, whether that be for healthcare, predictive maintenance, or AI for industrial inspection. So the course content kind of covers all different areas within NVIDIA. So a typical instructor-led workshop through the Deep Learning Institute is a full day, usually takes about 8 hours. We're doing a lot of these remotely now due to the pandemic, but also coming back online with some of the in-person workshops as well. So the benefits of an instructor-led workshop versus a self-paced workshop, obviously you get access to a DLI certified instructor who is very well versed in the content, who can answer questions and things like that. All of our workshops leverage what we call the DLI platform, which allows the students and developers to access fully configured GPU accelerated workstations in the cloud. And so there's no requirement or local requirement for GPUs. You really just need a internet connection and a browser to go through our courses. So this is a big data conference. So I just wanted to show one of the example courses called Fundamentals of Accelerated Data Science with the Rapids framework. So you can kind of see how the course is broken up into modules and into pieces. I'm not going to go into all the details about the course, but I definitely encourage you guys to check out our training courses. This one is also offered as an online self-paced course. So in terms of our online training, our online self-paced courses, again, the benefit is that you can take these anywhere, anytime. You just need access to an internet connection. Again, you still get access to the standard workstations, the GPU accelerated workstations in the cloud. There are videos and things that sort of try to take the place of an actual instructor, right? So this is nice. It's nice. There's useful ways to incorporate this into university classrooms that I'll talk about in a little bit. Again, even with the online training, you get access to certificate opportunities. Yeah, I'll talk a little bit about that. So again, the main remit of the DLI is to deliver workshops, both in the form of instructor-led and online self-paced. But we do have a few additional programs, special programs for educators in academia that I wanted to really focus on, because this allows you to get access to all this content and more for free to integrate into your courses. So the first program I'll talk about is our Teaching Kits program. So this is where educators can download full semester long, usually more than a semester long worth of content in source level format, as opposed to the DLI workshops that I mentioned. Those are very fixed in nature. You don't get access to any source code, or you don't get access to lecture slides and things like that. So the Teaching Kits makes a very good complement to the workshops and online courses. So what's in a Teaching Kit? So again, these are downloadable packages of pretty standard teaching content. So lecture slides, lecture videos. You get access to hands-on programming labs with source code solutions, sample solution sets. Some of the kits have larger coding projects, smaller Q&A problem sets for like quizzes. Some of the kits have an associated electronic textbook that comes free with the kit. And then we also bundle up all of those online self-paced courses, the fixed courses that I talked about before, in these teaching kits. And we co-develop these teaching kits with academic partners. So usually fairly well-known academics in these areas, right? So for example, we have what we call the Accelerated Computing Teaching Kit that covers a lot of the CUDA programming and GPU computing. And we co-developed that kit with Professor Wenmei Hu, who was at the University of Illinois, and a very well-known professor in the space of parallel programming, and wrote one of the most famous textbooks around the subject. So we really partnered with him to really bring all that content out to educators in the world. For deep learning, we partnered with Professor Yan Leku at NYU. He worked with us to package up his courses, and we put some touches on it as well. And again, that kit is very theoretical in nature, includes a lot of the math and science behind training deep neural networks, and it makes a really good that his course content makes a really good complement to the DLI core online courses that are much more application focused and hands-on focused. So it really gives students kind of a mix of, again, theory and application. And again, we try to be as flexible as possible in terms of what educators want to incorporate into the courses. We have a separate teaching kit around accelerated data science that focuses on the Rapids framework that we worked with Georgia Tech and Prairie View A&M University. And I'll talk a little bit about a brand new teaching kit that's coming out in Edge AI and Robotics that targets our embedded systems platform called Jetson Nano. So we have currently 4 courses out, or 4 teaching kits out right now. And so I'll talk a little bit more about those as we go. Educators can access directly these kits, there's a very simple application form that they fill out by following that link below, developer.nvidia.com/teaching kits. So again, all of these teaching kits are free for educators. So just a little bit about the specific content within the accelerated computing teaching kit. So this is the one that has the associated very tightly coupled electronic textbook. It's probably the most mature textbook on CUDA out there. It's in its 3rd edition now. And again, you get access to all different types of teaching content. This one's probably up to 2 semesters worth of content. So we routinely add new content into existing teaching kits and make updates and things like that. So I think this is in its like 4th update. So definitely check that out if you're teaching any parallel programming courses. And this is what the subject matter is covering. It follows the textbook pretty well. So we talk about the CUDA programming model, and over time we've added new architectural features from the newer GPUs into these modules. You have your popular computational patterns and algorithms, and how we accelerate those using GPUs. Case studies, and then we have other programming paradigms for parallelism using MPI or CUDA Python, OpenACC. So again, it's a pretty comprehensive package of teaching materials, and again, you get lecture slides, you get labs that cover all these areas. So the one that's coming soon, in fact, it's coming in a couple of weeks at our technology conference. It'll be released, is in again Edge AI and Robotics. So this one is a little unique because it actually targets a specific hardware configuration or embedded systems platform called Jetson Nano. There is also ways to access and get grants of the Jetson Nanos for free as an educator, and all that information will be released at the GTC conference. And I'll show you guys how you can get access to that conference as well. Yeah, it covers you can see some of the topics that we cover here. Again, all the labs and lecture slides come with it. And yeah, actually, I needed to update some of those dates because we're actually releasing here in a couple of weeks, not in summer. We're past summer. So again, on for GTC, I believe the date is actually November 9th is when we'll run this session that covering this new teaching kit. So I encourage you guys to sign up for GTC in general. I mean, there's thousands of sessions, and not thousands, but hundreds of really interesting sessions in AI and accelerated computing. But this is the one that is specific to the Teaching Kits program for educators, if you guys are interested. So definitely encourage you to check out that. So switching gears to the deep learning teaching kit. So again, this is the one we did with Jan LeCun. So again, that one has some specific content types as well. One of the unique things is that this content is set up sort of competition style. So some of the grading rubrics that we provide actually allow for kind of a grading session where the students can actually compete against each other. And again, we include all of that in the kit. And you don't have to use that rubric, but that's just that's the way that he was teaching his courses. So, and then these are the high-level modules that we cover in the deep learning teaching kit. The kit for a lot of the solutions was using the Torch frameworks. A lot of that has been updated for PyTorch. And again, we'll be adding more and more content as time goes to this kit, as well as even industry-specific content. For data science, this is the newest one that's available, and it's in its 3rd release right now. Again, it's probably almost 2 semesters worth of content. So all of your some fundamental topics in data collection and pre-processing, and then really, how we accelerate sort of the end-to-end data science pipeline with the Rapids framework. So that's an open source framework that has been well suited to GPUs. We cover other topics like data viz and graph analytics. So again, for data science, this one is really cool. We also work with a professor on this content at a historically Black college, Prairie View A&M University. And so there are some labs and some topics in there that cover bias and fairness in data science and challenges and important figures from underrepresented groups. So we're really excited about this content as well. Okay, so that's teaching kits, that's downloadable packages. Again, anyone who's teaching courses or even a teaching assistant at the university can get access to teaching kits with a basic application. And again, that's all free. We make all of that free for universities. The second program I want to cover, it's kind of a next level up program. So I mentioned that for our DLI workshops, those are taught by certified instructors, right? So they've gone through a process where Nvidia has certified them as an expert in that course, with also expertise in related subjects surrounding the course. And we do have a program where we can put university educators through the same process to get certified to teach our instructor-led workshops. And again, we do this at no cost. We offer the platform at no cost, and this is a popular program. It adds a lot more content to the Teaching Kits program, and a lot of the latest hands-on training content. Again, this is a way for universities to bring more instructor-led content into the classroom. We also see use cases where university educators will use these DLI workshops to apply for a workshop or a session at an academic conference, right? So that's a big thing, is getting workshops and things accepted at these academic conferences. So they use the DLI workshops to do that. It's nice. It's already all packaged up, and usually they have experience already teaching it. So if you guys are interested in becoming a certified instructor with Nvidia, there's a link there. I'll also provide one at the end. And we call this special group of certified instructors university ambassadors. It's basically a subset of our DLI certified instructors, and there's some additional benefits to being a DLI ambassador that I'll talk about here in a little bit. But so the basic process for instructor certification looks like this. So there's a basic application phase, similar to the way you fill out an application for teaching kits. Then we give you access to the course online. You'd go through the course, complete some instructor assessments. You take a platform management course, so that's how you actually use the DLI platform that I mentioned that taps into GPUs in the cloud. And then you actually have a short one-on-one live interview with a DLI master instructor. And so once all that checks out, then we award you with the instructor certification. You can go through this process for as many of the workshops as you want. And yeah, and we have some continuing education programs, and it's it's a big community of certified instructors, and they learn from each other as well. And again, there's some additional benefits to becoming a DLI certified ambassador, and namely, it's access to the world-class content is what we see most people seeing the benefit.
Mr. Bongo, you have 10 seconds left.
Oh, okay. I thought I had 5 minutes. Yeah, so there's benefits here. We can send out these slides at the end. Again, we have hundreds of universities where we have ambassadors today. Here's some links. Again, we'll send these out in the slide decks, I'm sure, of how to apply for ambassadorship, how to get access to the teaching kits. And again, I can't stress enough, GTC, that's our big technology conference coming up in a couple of weeks, November 8th to the 11th. It's completely free. It's a free virtual conference. Again, we have a lot of big names and speakers, and a lot of announcements coming there. We also have we also run the training courses that I mentioned before virtually. Those are also being run at GTC. Those do have a slight cost to them. but I encourage you guys to check that out. Okay. Thank you very much.
Thank you, Mr. Bongo. Okay, thanks all speakers. Now it's time for a panel discussion with our speakers. And we also have Professor Chun Ji-young at Seoul Cyber University. So all panelists, please turn on your audio and camera to join the panel discussion. Okay, so it seems Dr. Raja Mohan is here, and Professor Lee, Professor Chun, and Mr. Bongo. Okay, great. So in the panel discussion, we are going to talk about education and research in big data and AI. And I'm a moderator for this discussion. So I'm going to start with some questions to each panelist. And anyone of you who wants to answer this question, you could also join us as well. So I'm going to start with the first question to Professor Chun. Professor Chun, you have been teaching online for several years in many areas. And could you briefly introduce Seoul Cyber University and your online teaching experience? And also maybe do you have any difficulty in teaching AI classes online?
Thank you so much for the question. To give you some background, our university is a cyber university. The online lectures are not real time, and students can listen to lectures according to their schedule. Most students are mature students, and many have jobs as well. But their coding skill ranges depending on their major. So we have to design a curriculum that is adaptable for all skill levels. Our biggest challenge as educators is developing this adaptable curriculum related to AI and big data. We already have lectures for students who can use Python or similar languages. However, we are still working on building something for students without the necessary coding skills. Also, we are trying to find no-code or low-code AI tools that enable us to teach lessons related to AI and big data to all students who show interest in these fields. It would be great if Nvidia and Databricks could recommend some courses or tools for non-technical information students.
That's it, right? Thank you. To Dr. Raja Mohan. Databricks has been leading big data and big data machine learning. And as deep learning has been widespread with the GPUs, I'm sure Databricks has been adding GPU to Spark cluster. And what should be the killer application using deep learning, especially with the GPU in Spark? And for Databricks, how do the customers like it?
Yeah, that's an interesting question. So I would say almost any application that is data intensive or can be data parallel would be a killer application, because PySpark is sort of the ideal tool for large scale distributed data processing. So be it image data, text data, tabular data, any of those things you can basically just format to compute nodes and have them process over it. It's ideal for PySpark. So what you really want is sort of this the coupled Spark plus your deep learning framework of choice. So I will actually say that PySpark does have MLib, but with very limited functionality in terms of what you can do for either machine learning or deep learning. And I know the community is centered around tools like PyTorch and TensorFlow. So as I've shown in one of my slides, what you really want to do is have a very strong data foundation and ETL we're using PySpark. So as long as you can actually parallelize those computations in a data parallel way, you can apply to any application. And then what you would be doing is just if you're doing inference, you would just apply your model to your data. Or if you're doing training, you would do something like CoreWatt to extract the data batch by batch and do training on that from PySpark. So using things like Pedestal. So the thing I would qualify my answer by saying the things that don't work, for example, for something like PySpark, is tightly coupled code that is more compute intensive. So if you say you have small data, or if you want to run something like CFD code, that's not something ideal for Spark, right? It's more compute intensive than it is data intensive. So that's how I would qualify it. And Spark, the way Spark handles GPUs is Spark is primarily designed to work on CPUs. It allows you to integrate with GPUs using different mechanisms such as Pandas UDF or your library of choice.
I see. In addition to that question, there are many media related data like video and like audio, and I wonder if Databricks has any kind of approach to handle those kind of media data set.
Yeah, there's actually quite a bit of work happening with image. So we're starting with images and working our way to, so audio and images sort of have the same level of complexity, than the video is sort of the next step up. So right now, the majority of customers, I would say, are image data, and followed by much smaller number of people that have video data or audio data. I'm sure they exist, but in terms of our customers, the next type of data after text data or tabular data would be image processing. So we're working on data processing tools and data processing APIs for that. So an image, I'd actually skipped over most of the details in my example, but the one that I showed for Pandas UDF was actually loading images as a iterator batch and applying inference on that. So there are actually APIs out there currently that allow you to do that. And Delta Lake, if you think about it, is ideal. It's not constrained by many of the data warehouse designs. It's essentially just your file format of choice, and you can put anything into Delta Lake, essentially.
Cool, thank you. And this question is to Professor Lee. Professor Lee, you showed us very interesting, like the metaverse, the apps research. And mostly the university needs hardware and software resources to participate in real project with the students, which handle massive data set. In your case, it should be like a video data set. What resources are not enough for your research, and what collaboration or support may you need from the companies like Databricks and Nvidia for your research?
We in our research, we keep the data set in our site. So in order to handle such a data set, we need a lot of hardware resources, such as a graphic card, RTX 3090 or A4000, and should be important. So in order to, collaborate with the Databricks and Nvidia, and so in the Databricks, they plug in the Spark in their application, or also they provide some software tool to manage big data database. So, but personally, we have tried to build up such a database in our laboratory before, but the configuration is not so easy. So I think if Databricks provide us some clouding resources and to test their application tool to manage the data set, it would be great, because we don't need to configure all the things. Everything is configured, and then we just get into the clouding server and then try to use their data set, and also trying to use their API. That much easier rather than just configuring the Databricks software personally. So that is one thing. And then in the Nvidia, I think they provide some curriculum, but the major thing is if we just practice their curriculum, is it really helpful to understand the insight of AI? That is a critical point. And so if we follow up their curriculum, but we don't have so much insight on it, then nobody want to use it. And so so sometimes they open their software to make speed up the program in the GPU and something like that. So we need to get more information from the Nvidia curriculum. Yeah, so after we figuring out what type of software and what type of parallel processing implemented in the source code, that should be important to us.
Thank you, Professor Lee. Mr. Bongo, you want to add something about your curriculum that, as Professor Lee mentioned?
Yeah, I mean, we get a lot of requests for, and apologies if I misunderstood the question, but we do get a lot of requests for a deeper insight into how the GPUs are designed and how that can help students get a better understanding of sort of what's happening under the hood. I think there's always a trade-off between those types of requests for proprietary information and what the students actually need to learn, right? So I think a lot of what we focus on is more on the application side. What can we provide for the students to build accelerated applications as quickly and easy as possible without having to understand the underlying architectures and all those details. So that's kind of where our focus on is more on the application side of things. If that helps.
Sure. Also, based on my experience, when I look through the fundamental deep learning training courses from DLI, I believe that was very helpful. It was easy to deliver to the students.
That's great.
Yeah. And also as the Professor Lee mentioned that, at the university, we need to focus on the application or some research by building some models, but because we don't have enough resources, we don't have the hardware resources, many students need to spend their time to configure server and a software to install instead of focusing on their research. So I absolutely agree with Professor Lee. We need to focus on application and research, but we spend our time for configuring our servers. Yeah. So if we have Databricks definitely support with some credit to use their service. So that could be helpful, but yeah, definitely we need that kind of services.
So,
and now, go ahead.
I just wanted to add, there is our Databricks community cloud, which is free to use.
So,
so anyone can actually log in. You don't need a credit card to use any of that. So there's limited resources, but there's still resources for you to try out most of the functionality that Databricks offers.
Exactly. Yeah, I've been using it, and that was great, and my students are really love it. Now let me ask Mr. Bongo. Nvidia DLI provides a number of useful AI and data science courses and workshops for university educators, which already provide a full hands-on cloud-based platform. However, the DLI platform is not accessible for educators to modify to meet their exact needs for their university courses. Does Nvidia have any plan to enable direct cloud services to the universities?
That's a great question. Actually, one of the most important aspects of the Teaching Kits program that I talked about, I forgot to mention, was that we package up AWS cloud credits with the Teaching Kits. So we, Amazon Web Services partners with us to enable us to give credits to both students and educators for every course. So there's a standard dollar amount that we give up front, and if they get past that amount, then they can come back to us and ask us for more. And Amazon is happy to work with us on that partnership. So again, that gives sort of a raw cloud compute access where the students can then run and develop those labs in the Teaching Kits that we talked about before, so they don't actually need any local hardware or access to clusters on university campuses that are usually relegated for research activities as opposed to teaching, right? So that's the way that we scale, is with the partnership with AWS. Of course, you know, the content also works with any other GPUs that you guys have access to. You know, if you do have local resources and things, and yeah, and like I talked about, the teaching content is really the core content that is designed to be flexible, so so educators can take that content and modify it as little or as much as they want, right? And as opposed to the DLI workshops, those are very fixed. Again, they are what they are, and again, they make a good complement to the teaching kit content that is very easily modifiable for each educator's needs for their courses.
Joe, it sounds very interesting. I'm pretty sure many the professors here love it, and I'm gonna share any link to apply for the credit after the workshop.
Yeah, the first step is to get access to the Teaching Kit program, and then from there there'll be further instructions on how to get access to the cloud credits.
I see.
Yeah.
Okay, great. Let me try that, and if it's not easy, then I'll ask you again. Thank you.
Yeah.
And this is the question to Dr. Rajamohan from Yonsei University Health Systems. Yeah, my friend, like Professor Yu there, asked me to ask you, like, Yonsei University Health System is one of the largest hospitals in Korea, and it has started to build a research data platform based on Amazon AWS cloud for secure, scalable, and reproducible research. And the hospital planned to develop 100 terabyte data lake by 2022 and wants to expand it to 1 petabyte by 2024. And he thinks Databricks seems promising for building a data lake, harmonizing diverse structure and unstructured medical data, and for analyzing it. And he wants to know if Databricks have any experience in the area of medical and health industry with this massive data set. And also, if you have, do you have any link to share for us to take a look at?
Absolutely. So healthcare is actually one of the bigger verticals that Databricks has. And I'm not sure how I share a link here. Is there a way?
Oh, you could email me later. I could share it with the people.
Yeah, essentially, if you search for Databricks Healthcare Industry Solutions, you should get that in the first 2 hits. So we have what's called solution accelerators, and those are essentially templates for how to get started with Databricks for a particular industry. So it could be by application, it could be by industry. So if you search for Databricks Healthcare Industry Solutions, you should get this healthcare specific industry vertical solution that shows you everything as a healthcare industry provider that you need to do to use Databricks for your problems. So we have a variety of big name customers. CVS Health is one. I think we've showcased a few of them here, so you can listen to some of their testimonies and how they actually went about building an architecture. And petabyte scale and terabyte scale problems are not new with Databricks. Most of those people are working at that scale, which is why they use companies like Databricks, because they don't want to manage the infrastructure.
That sounds great.
Yeah.
I'll search for it, and at the same time, do you mind if you
I will
send
I will
me
email
the link? And one more thing. What customers, health customers, you guys have been working with?
So I know there's Sanford Health is one, CVS Health is another one. So CVS did the pharmacy.
Got it.
So those are the two ones that I remember. I am sure we have more on our healthcare page. So working with patient data, hospital data, medical imaging, these are all things that Databricks normally does. And if you search our blog posts, it's another source for good information. I've written a lot of blog posts, mostly for text processing. Don't do a lot of image work, but essentially for things like processing, healthcare data or patient data and things like that. NLP work, you'll find a lot of solutions architects writing posts on what they did with their customers. So those are also good places to start. But the first place is definitely the solution accelerator page.
Got it. Thank you. And also this is for Professor Chan. I think you already have heard about something from the industry, I mean, Databricks and Nvidia, but yeah, if you have, please let me know. Professor Chan, you may resolve the technical issues of the online classes, collaborating with the industry. Do you need any collaboration or support from the companies like Databricks and Nvidia for the course?
Yes, I just want to ask Mr. Bongo. So Mr. Bongo, I'm very interested in being able to offer additional certifications to my students. So if I were to qualify and take your instructor course, would I then be able to offer courses that would give students certificates?
Yes, absolutely. So, so you can go through the process to be a certified instructor for specific workshops, and then you can deliver that workshop as an instructor-led workshop to your students. And then in those instructor-led workshops, the students would have the opportunity to take the assessments that are built into the course and achieve a student certification for each course. We also have another model where if you don't want to go through the process to be a certified instructor, you can just get access to the teaching kits, and bundled with the teaching kits are additional promotional codes for the free online self-paced versions of the DLI courses. And even though they're designed for students to take those courses on their own, you can also deliver those in a live setting if you want to. The experience is not as good because it's designed to be online self-paced, but we have some flexibility there. Either way, if the students take the online self-paced version, those also offer student certificates. So you can offer them as an instructor-led workshop, or you can have them take them online self-paced, maybe on their own, as part of some homework assignment or something. And then they can come back and they can show you their unique certificate. Every certificate has a unique identifier so that they can prove to you that they achieved certification.
Thank you for sharing your time and expertise with us. Thank you.
Yeah, absolutely.
Thank you. And this is for Professor Lee. As a professor for teaching and research in metaverse using big data and AI, and do you have any other questions or requests for Nvidia and Databricks?
Yeah, so there are also Korea branches, and so I think we made an agreement with teaching using the Nvidia course material. So how can make a connection between the Nvidia in US and Nvidia in Korea, and they provide such a service to university. So if we just make a connection with the Korea branches, then is it okay, or is there any additional, additional information we need from the US online? And so that's a little bit curious. And also in the Databricks, if we want to use your clouding service, right? And so are you able to provide us some account for the university? And so, and then we try to build up our data set using the Databricks. So that's my question.
Cool. Joe, you want to start it first?
Yeah. So most of our programs, especially when it comes to curriculum and research support through hardware grants or whatever it might be, those tend to be global programs. So I think it's probably always useful to have a local contact in Nvidia Korea, but it's not 100% necessary, I think, unless you're wanting to purchase GPUs for the university or something. But yeah, I think it's fine since our programs are global that you can work directly with me as well, or get access to the content and resources yourself online.
Yeah, so also NVIDIA is going to provide some clouding sources if we follow the course.
That's correct. Yeah. So so there are some links in the presentation, and we can send them out to everybody as well of where you can join these programs to get access to cloud credits, curriculum, and all of that.
Okay.
Sounds good.
And speaking for Databricks, I just want to say, if you deem that the community cloud or the free version of Databricks isn't sufficient, there is the University Alliance program that you can make a request to get free credits. The specifics of what you need to put down to get those free credits, I am not sure. Rob Reed is our program manager for the University Alliance, so I can give you his email information so you can get in touch with them and find out how you go about doing that. I do know that they make credits available for teaching purposes. For research purposes, I think it's a little more difficult, but I don't want to say anything, so I will defer that answer to Rob Reed, who can answer that question better.
Sounds good. Actually, I invited the director of University Alliance, the Rob Reed. I'm pretty sure he's watching this the symposium right now, and I will definitely share that information with the purpose.
Yeah, he just had to leave to another session, unfortunately. So I will ping him and make sure that he gets you guys a response.
Okay, sounds good. Thank you. And Dr. Raja Mohan, does Databricks have any plan to build the APIs for deep learning, such as CNN, RNN, GANs?
Yeah, so Databricks really wants to build the components for that ML ops or the machine learning pipeline. So that differs from building things such as CNNs or GANs, because there are already folks working on GANs and CNNs or BERT transform models. So Databricks might work on using those things, and in the odd times they might actually provide certain functionality or libraries that might help our customers. For example, we open source this library called Tempo for time series forecasting. But other than that, usually Databricks does not spend a lot of time actually coming up with libraries unless it fits into something like MLA. So we say we want to expand out the functionality, but chances are things like GANs, what you would find in PyTorch and libraries like Transformer, we're probably not going to try to reproduce because there are other people doing that better. So we want to integrate and use folks who are dedicating their time to that instead of replicating their work.
Awesome. Thank you. Question for Mr. Bongo. The teaching kits appear to be an amazing resource for professors and instructors teaching courses in the area you mentioned. Are there any plans for teaching kit in different areas, including where data science and deep learning are being applied in industry and academia today?
Yeah, so we're always planning, exploring new teaching kits and updates to existing teaching kits. So I can't go into too much specifics about what's coming down the pipe. I can say that we what's on the horizon is something we're pretty excited about. So we're working on a new teaching kit with a very luminary professor in the areas of deep learning for science and engineering. So how to apply deep learning in areas like engineering physics, systems biology, geophysics, bioengineering, and chemistry. So we're planning to release that kit probably sometime next year. So again, joining the program is kind of the first step to being the first to know when that kit will be released. So science and engineering, we're also looking at developing curriculum for graphics and simulation. We're looking at some new content for automatic speech recognition, as well as deep learning for healthcare. So those are kind of in the exploratory phase right now. Of course, we have training content workshops covering these areas already, but they're not packaged up in a useful teaching format, right? Where educators can take the stuff and modify it and use it how they need. So that's coming down the pipe. So again, if that's interesting to you guys, again, join the program. You'll get updates on when that stuff is available.
Thank you. Yeah, I think it's about time to wrap up. And yeah, actually, this is all we have. And thank you, our speakers and participants of the symposium. I'm pretty sure you have enjoyed the symposium. And thank you all again. Have a wonderful day and evening.